The second OSPF design we are going to take a look is multi-area OSPF, which is a way of limiting the amount of neighbors in an area. So by using multi-area OSPF, we are having smaller link state database and routing tables, and we are making rare SPF calculations with our routers within that specific area. So this design is a suitable solution for large networks to decrease the processing overhead. As you can see here, we have multiple areas and each area is connected to area 0, which is the backbone by an area border router. And each additional area in OSPF domain must have a connection to OSPF backbone area, as I told you. Such connections are maintained by an interconnecting router known as an ABR, and an ABR, guys, maintains separate link state databases for each area it serves and maintains summarized routes for all areas in the network. Okay, I have given you one example. If a link between router 8 and router 9 goes down, area border router, which is router 2, isolates the fault also. So just area 50 is affected from this change. And we have another router type in multi-area OSPF. Okay, so that is known as Autonomous System Boundary Router, ASBR this time. Okay, the other one is ABR, which is connecting the other areas to the backbone area. And we have our Autonomous System Boundary Router, ASBR. That is a router and that is connected by using more than one routing protocol, and that exchanges routing information with routers' autonomous systems. So ASBRs, guys, typically also run an exterior routing protocol such as BGP or use static routes or both, and it is used to distribute routes received from other external autonomous systems through its own autonomous system. So here you can see that we have our area border router, which is router 2, and this is connecting area 50 to area 0. Here I don't have any other areas, and this router 3, it is directly connected to internet or any other routing protocol domains. Maybe it is an eIGRP domain, okay, which means there are routers in here which are running eIGRP, and if those routers send some information to the router 3, this router 3 should somehow inject this same information to this area router 1 and router 2. Okay, so again, what is an ASBR? It is a router connected to the internet from one of the interface or to another routing protocol domain such as eIGRP. Okay, so in OSPF we have types of the LSAs. Okay, so this is an important chart, guys. So mainly we have LSA type 1, 2, 3, 4, 5, 6 and 7. Okay, so LSA type 1, it is known as the router LSA, and it is generated by the all routers to describe directly attached links. Okay, so router LSA does stay in the area itself. Okay, it doesn't leave the area that is generated and used to describe directly attached links. We have LSA type 2, that is the network LSA. That is generated by designated router to describe the neighbors connect to that segment. And this one also does not leave the area that it belongs to. We have LSA type 3 and 4. Those are known as summary LSA and generated by ABR to describe a route to ASPR, to neighbors outside the area. We have LSA type 5, that is the external LSA, that is generated by ASPR to describe routes redistributed into the area. So as I showed you in previous slide, the ASPR router, it is connected to internet or any other routing domain such as EIGRP, REAP, etc. So these routes will be sent to this ASPR, and ASPR will share it within the area that is connected to, right? So how it is doing it? It is doing by the help of external LSA, which is LSA 5. We have multicast LSA, that is LSA number 6. It is used in multicast OSPF and not supported in Cisco. And we have LSA number 7, that is generated by an ASPR in an NSSA area to describe routes redistributed into NSSA area. So let's have a look to the OSPF routing table. Okay, so in here, if I go ahead and run the show IP route OSPF command, I will see something similar to in here. Okay, I have routes mentioned by O, for example. Those indicates that the route which is learned via OSPF. Okay, this is learned via OSPF from another router. Okay, so I have OIA. Okay, so OIA indicates the routes which is an inter-area route. Okay, so basically that is coming from another area. And I have here OE1 and OE2 routes. This E1 and E2 indicates that the route is an external route from another routing protocol. As I told you, an ASPR might be connected to an external routing domain. This is ASPR, and maybe it is connected to an EIGRP domain, and this one will send to the ASPR, and ASPR will send it into the OSPF domain as an E1 or E2 type route. So OSPF route summarization. OSPF route summarization, guys, is a technique again used to aggregate multiple IP address prefixes into a single summarized route. So this helps reduce the size of the OSPF routing table, decrease CPU and memory usage, and improve overall routing efficiency. So in an OSPF design, just ABR and ASPR routers can summarize the routes. That is very important. So when it comes to the types of summarization, we have inter-area summarization. It is performed at ABRs to summarize routes between different OSPF areas. And we have external route summarization that is performed at autonomous system boundary routers for summarizing the external routes. I mean the routes learned from the other protocols. So if you have a look in here, I have area 1 and I have area 0, and this is my ABR. So in an OSPF design, again, just ABR and ASPR can do this route summarization, right? So here I can see that this router 5 is performing an inter-area summarization. Okay, we have this prefix 10, this prefix 20, we have this prefix 30, and all of them are with a subnet mask of 24, and this router 5 is summarizing all those networks in here as a single network with a subnet mask of 16 to router 6 in here. So ABRs, guys, they can summarize the routes between the backbone and the other areas. Okay, just keep in mind. So again, similar to the example I have given in the previous slide, I have area 50, area 0, and area 60. So my ABRs are router 2 and the router 3. Router 2 is connected to this area 50 and it has 1.0 and 2.0 networks with a subnet mask of /24. For example, it has the capability of summarizing these two networks as a single network with a subnet mask of /22 to router 1. Same applies to the router 3. It is connected to this area 60, which has a network of 1.0 and 2.0, and it has the capability of summarizing these two routes as a single route with a smaller subnet mask, which means it can cover both this address and this address as well. On the other hand, as I told you, ASPRs can summarize many external routes into one LSA, and that was LSA type 5. So let's go with the multi-area OSPF configuration. This is how I'm doing the configuration for multi-area OSPF. So let's have a look to the router 2. Okay, I'm typing router OSPF and the process number, that is router OSPF 1 for this case. And what I am doing first, in first stage, I am defining my router ID. Okay, so for simplicity, I am giving it 2222 only. Okay, router ID 2222. Then what I am doing, I am defining the interfaces that will join my OSPF. How I was doing it? I was doing it by using network command. Okay, for this router, I have two different interfaces. Okay, one of them is with network ID of 104150. The other one is with 104126.0. So since I want both interfaces to join my OSPF domain, I am typing the command as network and the network ID of these interfaces are connected to, which is 104150 and 104126.0. And then I am using a wildcard mask, and that is the reverse of my subnet mask. Okay, so a /24 can be represented in this way, right? 255.255.0. So my wildcard mask that I should use in my OSPF configuration is 000 and 255. Just put 0 instead of 255, just to put 255 instead of 0. That is just for simplicity. So same applies to the network in the below 104126.0. That is the network ID with a subnet mask of 255.255.255.0. Even it is not mentioned in here, it will be /24, which is 255.255.255.0, and the wildcard mask will be 000.255. Okay, so the syntax is network ID, and the wildcard mask. Let me write in here network ID, and the wildcard mask followed with area keyword and the area that interface belongs to. So for this network, it will be area 50 because this network belongs to area 50, right? 1041.50.0 belongs to area 50. And for the network on the below, 1041.26.0, it will be area 0 because this network belongs to area 0. Okay, so this is how we are configuring the OSPF version 2 for multi-areas. And this is how I am defining the multi-area OSPF for OSPF version 3 for the IP version 6 networks. Okay, basically what I'm doing this time is first I need to type, there is a small syntax error in here. This command will be IP version 6 router OSPF 1. Okay, in config mode, I am typing IP version 6 router OSPF 1. Then I am defining my router ID, but then there is a slight difference compared with the OSPF version 2 configuration in OSPF version 3. Okay, for router 2, what I am doing this time, I am going into the interface mode, interface gigabit 00, and I am typing IP version 6 OSPF 1 area followed with the area number. Since this gig 00 is belonging to area 50, I'm typing area 15 here. And when it comes to the gig 01, which is here, I am doing the same thing. IP version 6, OSPF, and process number followed with the area keyword and the area that interface belongs to, which is 0 for this example. So here is I am configuring the route summarization. Remember, in OSPF multi-area design, only the ABR or ASPR is capable to do route summarization. So when it comes to the example, we will have a look to the router 2 again. And first of all, in the config mode, I'm typing router OSPF 1 and going to the config router mode. And then what I am typing is, first of all, area and the area of the source routes. Area 50 this time is the source of the routes that I will summarize, right? So the command is area 50 range is the keyword. And I am using 1041.00/22 to summarize it to area 0. So, and lastly, I will have a look how I can verify the OSPF version 2 and OSPF version 3 configuration. Here are the commands that you can use for verification, okay, to see the hello timers, dead timers, router IDs, LSA types. Those type of information will be displayed by using the commands that you are seeing on the screen. Only difference between OSPF version 2 and OSPF version 3, use just IP version 6 keyword instead of IP for the OSPF version 3. Alright, we are coming to the end of this section as well, and thank you so much for listening to me.